My name's Phil Williams and I would like to welcome you to Audio Angling, the podcast site of fishingfilmsandfacts.co.uk. Last summer, which was 2012, I received a request from fishery researcher James Thorburn at the University of Aberdeen to record length and girth measurements, sex identification and to remove fin clip samples from 30 taupe taken off the Lancashire coast. Similar requests also went out to anglers and charter boat skippers in other parts of the country in an effort to accumulate data from as wide a geographical range as possible across the UK for a Ph.D. research project looking into the population dynamics of taupe and spur dogs as a follow-on from tagging work done with the Scottish Sea Angling Conservation Network, SACN. Both James and I have been out gathering further samples today in Luce Bay, and hopefully we'll be out again tomorrow aboard the Dromore based on Newmark skippered by SACN Projects Director Ian Burrett. It's evening now at the end of day one, and we're sat out on Ian's front porch looking across the sunlit calmness of the bay and hoping it stays that way for tomorrow, before we retreat to the pub for a couple of beers and some food. So I'm grabbing this opportunity to talk to James about the project's objectives and potential value, and maybe even discuss some of its preliminary findings. So to set the scene, explain to us the basic aims of the project.
The project, as it stands, is to explore the movements of two species of shark that are native to Scotland. We're looking at the taupe, Galeohynus galleus, and also the spur dog, Squalus acanthius. Now, the reason that I chose these two species rather than any other of the shark species swimming around the British Isles is mainly due to the fact that, first of all, they're species that are targeted by recreational anglers, and therefore access to them is actually relatively easy compared to some other species. The other reason is because they were the focus of the Scottish shark tagging programme, and there's already a wealth of data of mark and recapture reaching back into the 1970s. At this point, my interest in the two species slightly diverges. You've got the spur dog, which is actually a relatively well-known species around the British Isles, subject to a lot of fisheries interest in the previous century. For over the last 100 years, they've actually been active fisheries targeting them, and throughout Europe, that is, not just in the British Isles. And there's still a very active fisheries interest in them due to a massive population decrease over the last 30 years or so. Now, when I say a massive population decrease, I'm actually talking about a 95% reduction in biomass within British waters. So this species actually has comparatively quite a lot known about it compared to a lot of the other shark species. However, what is unique to my work is the fact that rather than look at the more offshore populations, due to the angler interest, I'm focusing on more inshore stocks, especially the stock around the Firth of Lorne, Oban, and focusing on Loch Etive on the west coast of Scotland. Now, the reason that this differs a little bit from the taupe is in the northeast Atlantic and around Europe, the taupe is data deficient, as classified by the IUCN. We know very little about it. Worldwide, it's vulnerable, and in Australia and New Zealand especially, there's actually quite a lot of work going into it, so it's an active fishery, but in the northeast Atlantic, we know virtually nothing about it. So we've got two species, very similar characteristics: long-lived, slow to mature, low fecundity, i.e. low number of pups. But we've got two extremes of the scale where relatively large amount of data known about species, and it's shown to have suffered huge population decrease, to the taupe, which we basically know nothing about. We don't know whether the population's healthy, if it's suffered massive decreases. There's no baseline data there for us to work on, so that's really where I'm coming into this project. So, just to actually sort of explain a little bit about how I'm going to focus my work on these species. As I mentioned to you before, there's already a wealth of data in the form of the Scottish Shark Tagging Programme's mark and recapture data set. This is a continuation. Some of the taupe data actually came from the Glasgow Museum's tagging programme, mainly focused on skate, but there's some taupe data there. Problem with mark and recapture data is it's fantastic at showing us movements, i.e. a fish was caught at point A and travelled to point B. The big problem is it doesn't actually show us the route it took or what it did in the interim period. So as I said, we don't really know what the animals do between marking and recapturing. Their kind of movements and their behaviour is unknown to us. So I'm going to undertake a multidisciplinary approach. So I'm working with Francis Neate at Marine Scotland, David Bailey at Glasgow University, and also Kath Jones and Les Noble at Aberdeen University. These are my supervisors for my Ph.D. project, and the reason I've got so many supervisors is because they've each got their own area of specialty. So I'm analysing the mark and recapture data, which shows us the extent of movements, for instance, taupe from Scotland to the Azores, Mediterranean and Iceland. While Spurdog have got a really interesting feature about their mark and recapture data is the fact that all recaptures we have for Spurdog have all been within the same geographic location as originally tagged, and the time difference is, days, months, years, so it's showing that they've got a strong site affinity, i.e. they have a strong pull to that certain area. This is Loch Etive on the west coast, as I mentioned earlier. So to try and look at the interim period, I'm going to be using something called data storage tags or archival tags. These basically log environmental parameters such as light levels, temperature and depth. They continually record this, and when we get the tag back, you download the data and we can start to recreate the animal's behaviour from this both vertically and horizontally. These will be going out on both Spurdog and taupe. I've already had quite a lot of success with the Loch Etive Spurdog. We got some tags back and it showed a really interesting movement where the fish came out of the loch, went into the Irish Sea and came back in it again. This is unknown in Spurdog. The taupe, we're currently putting out a load of data storage tags. So any anglers out there who like taupe, they should keep an eye out for bright orange tags on these taupes. They're actually worth about £100 each if you return them. Further, building on top of the data storage tag work, we are also undertaking DNA analysis, population genetics. Now this involves an army of volunteer, mostly anglers, a few commercial skippers as well. I'm also working with CFAS on this one, the agency down in England. Basically all it is taking a small tissue sample from the back edge of the dorsal fin. It's very unintrusive, the fish isn't harmed in any way. I can't say it's not damaged because obviously we're removing a small piece of the animal's body, but it's literally about the size of my little fingernail. But from this small piece of tissue we can get a whole host of information. We can recreate certain areas of its DNA, get its genetic code. Now the idea behind this is we're going to look at specific areas using what we call mitochondrial DNA markers, i.e. focusing on the mitochondrial DNA, which is very specific and passed down from the mother, not the father, only the mother. So as well as looking at the mitochondrial DNA, we're also going to be looking at the genomic code, i.e. the rest of the DNA, which obviously contains certain aspects of the both parents, i.e. the male and the female, and we're going to use something called microsatellite markers to select areas of this code to compare. Now what we're hoping to find is any sign of breeding between certain areas. For instance, we're sampling at the taupe, we're sampling animals all over Scotland and the rest of Europe. We'll compare the DNA from each of these locations and see if there are any genetic differences, and if so, how much. This allows us to begin to infer the amount of migration that happens between these locations. For the Spurdog, very similar, although our question is a little bit different. We want to know how much the population in Loch Etive mix with populations around the rest of the UK.
And when you collected these data, what are you hoping or expecting to infer from them in terms of what might perhaps need to be done to protect both species in the future?
As I mentioned earlier, a lot of the current work around the British Isles on Spurdog, or a lot of the current literature, is tended to focus on Spurdog populations that are in more offshore environments. They're still on the continental shelf, but they're away from our coastlines a little bit. And most of the data would seem to suggest it's one large population that moves around the United Kingdom. I'm not denying that. Spurdog do undertake huge migrations, including transatlantic migrations from the UK to America. However, work in other areas, i.e. the east coast of America, Canada, shows that population dynamics of Spurdog is much more complicated. I.e. the population subdivides into smaller subunits based on sex and age, and that these subunits actually can undertake different movements. Some remain very localised, others move to an offshore environment, some prefer coastal environments, some move in the open ocean. And these animals are always continuously moving between each other's. I mean, environmental parameters such as temperature seems to play a very important role in the movements of Spurdog. So what I'm hoping the genetics will show is if, in fact, we have a case in the UK where, as previous work would suggest, it's one large population, or in common with populations in other parts of the Spurdog's global range, we actually have a much more complicated picture where the population is split up into these subunits. Now, it might be the case, and genetics should help us answer this, that some of these subunits, for example, the population in Loch Etive, is isolated and doesn't mix outside of its own little isolated environment. If that's the case, conservation for these animals is obviously a priority to ensure that we have maximum genetic spread, but it's also very important because it shows that a certain facet of our UK population remains in a very localised area, and therefore a stationary management of the species, such as a marine protected area, might actually be a useful tool, while previously a lot of people argue that for highly migratory species, having something static like a marine protected area is actually ineffective at protecting these marine animals, because they spend such a little time in one area. So to protect an area, you can't protect it as soon as it's moved outside of that area. While if we have the case for the spur dog, that it's actually static for long periods of time, then a marine protected area as a management would actually be very effective. Moving on to the taupe, the genetics is actually trying to answer something slightly different. As I mentioned earlier, we have very little knowledge about the taupe. We know there's some movement from Scotland to the Azores, Scotland to the Mediterranean, and we obviously know that there's populations all around northeast Atlantic, very ubiquitous. They're in temperate waters throughout the globe. However, again, we don't know how much this mixing takes place. We might be monitoring the movements of one or two nomads, one or two highly migratory individuals. It might be the case that the UK population doesn't mix with the rest of Europe. If that's the case, again, we need to stop looking at taupe in the North East Atlantic as one large stock unit, and we need to management more appropriately, i.e. we need to look at the UK population of taupe, the French population of taupe, the Portuguese population of taupe. Because if one area is targeted, I mean, this isn't an issue in the UK due to the fact that there's no commercial fishing for taupe, and even in fact in the rest of Europe the keeping of taupe as bycatch is prohibited. But it's just to get us to think about taupe a little differently from a large stock unit. It's to try and fill in that data deficient into a known quantity.
It's funny really, because when I first started fishing back in the 1970s, Halloween Wheeler described the spur dog as the most prolific small shark species in northern European waters. Yet 30 years on, it was virtually extinct. So what happened in between, and is it now finally attempting a sustained comeback?
You hear many stories when you chat to the commercials, especially the gentlemen that have been fishing for the last 50 years or so. Spur dog are a pest, rats of the sea, I've heard them called. Huge shoals, I'm talking kilometres long, very deep. And the problem with them is, obviously, they've got these huge dorsal spines in the front of the first and the second dorsal that become entangled and destroy fishing gear. So they were the blight of the commercial market until other food stocks ran low and spur dog became an exploitable food source. You might have heard of rock salmon, for instance, in fish and chip shops. I know it's very popular in southern England, especially, or it was very popular. I believe you still get it. That was actually spur dog. We were eating spur dog. It was very popular. Now, I mentioned a little earlier that we are quite lucky in the fact that because spur dogs had a commercial interest, we've actually got a lot of background data on it reaching back into the 70s and even the 60s. Now, in around 70s, 80s, there's a huge population decrease. 95% is the figure that gets thrown around. That's a 95% reduction in biomass. So that's not only a reduction in the population, but it also means that that's a lot of the larger fish have been removed. The problem with spur dog is they're not massive sharks. You know, they don't even go up to 2 metres. You're lucky to get up sort of 1.5 metre maximum size. And due to the life characteristics of spur dog, 24-month gestation period, the females have to be very large. So the females are considerably larger than the male fish to enable them to develop these relatively large pups before parturition, before they're born. So for the commercial interest, they want the bigger fish because they're worth more, so they tended to target mature females. And obviously you're removing that, which doesn't allow the population to replenish because there's no females left to breed. And the larger the female, the more pups they can have. So you've got a situation where the animals that are most likely to enable a population to recover have been removed. Now, because the commercial interest in spur dog has disappeared due to protective measures, they're no longer kept as a bycatch, and there's certainly no targeted fishery for them. The animals that were actually born in the sort of 70s and 80s are now become big, mature adults, and they're able to recruit back into the population. They're able to replenish the population. And it's a little bit early days at the moment, but you're certainly beginning to hear stories again of these large shoals of spur dog moving around. Certainly the case here in Luce Bay. If you talk to some of the local skippers, they'll tell you that the spur dog population is apparently increasing again. So, as I said, I haven't got any fishery statistics or anything because there aren't any. There's a few bycatch information out there, but obviously the landings information, which is so useful to see population trends, has disappeared. But it seems to be on the road to recovery a little bit more. It's certainly not decreasing.
And presumably, because they tend to live in single-sex shoals, when the commercials were hammering the big females in pup, they were hitting the species disproportionately hard. There may well have still been spurs left in the area, but if they were all males, then the population would quickly become unsustainable.
Yeah, that was a big problem. I mean, unfortunately this is a trait shared by many sharks and skate species. They like to split their populations up. They don't swim around as a large unit, their populations tend to split up. Now these splits are mainly based on either the sex of the fish and also the age, or more appropriately the size of the fish. Now, a common trait is that immature fish, both male and female, will start to clump together, while as they get bigger and begin to mature, the male and female separate. There's a number of hypotheses as to why this is. Some people think it's because males and females prefer slightly different water temperatures. Due to embryonic development, females prefer slightly warmer water, while for sperm production, cooler water favours the males. Change in diet. Obviously, as I mentioned, females have to put a lot more energy into embryo development, so they need a higher energy diet or more available food source, and that subdivision of the sexes actually removes competition for the food source. There's lots of other sort of little theories, but generally along those lines. And as you mentioned, I mean, many anglers will tell you when they're fishing, they'll have a day when they only catch males, only catch females. And you're right, when the commercials found a large shoal of mature females, they were catching very little else, and it was a gravy train. They had an awful lot of money coming in over the side of the boat because it was large, mature female fish, and to them that was the most profitable.
When they're caught in a late stage of their gestation, they will often start aborting the pups all over the deck. When this happens with anglers, they tend to put the pups back. But would that realistically make any difference? In other words, would they be viable?
Yeah, it would actually. That would make a huge difference. I mean, as humans, it's quite hard to get around the concept of something that's born is actually immediately independent. I still hear people gasp when they see a newborn horse or a calf or even a giraffe at the zoo, for instance. It's born, its mother gives it a bit of a lick, and within minutes it's up on its feet. Now what you have to imagine is sharks are basically born as toddlers or even infants. They're immediately independent. They have no mother care. All the care that the mother's ever going to give it has taken place inside its body. When the animal leaves the mother, or in some shark cases the egg case, it's fully independent. It can hunt by itself, it's able to swim by itself, and it's able to look after itself. So yes, when pregnant females are caught on decks, and this is a common story I've heard from anglers, it happens with other sharks as well. Due to the excitement and, the limited stress caused by the capturing incidents, the female does give birth on the deck. Now, if that happens, those pups would have been very close to birth anyway. They're not aborting fetuses, they're not aborting very young animals that needed another few months. They're aborting animals that were a couple of weeks away. So although they're slightly smaller than they would ideally be, putting those fish straight back into the water, I'd be fairly confident to say they'd go on to live a fairly normal life.
Even with the yolk sac still attached?
Even with the yolk sacs attached, yeah. Some spur dog are born with the yolk sac still attached. A lot of the time that should have been used up in the female, but not all the time. They are born with the yolk sac still attached. There are stories of these animals being caught in trawl nets and even by anglers. Sometimes when you catch a young spur dog, if you flip it onto its back, between the two pectoral fins, you actually see a very thin scar. It's about 1 centimetre long, and depending on how well healed it is, it can be anything from a slightly raised lump to almost like a translucent line. This is where the yolk sac's attached. If you want the paradigm, it's basically the same as our belly button. This is actually a great sign that that fish is less than 4 to 5 months old. That's how the yolk sac's fallen off and it's healing. But yeah, even with that yolk sac attached, it hampers swimming a little bit, but they will live off that yolk sac much as they would inside the mother. But they'll use up that yolk sac, it'll drop off, and they'll go on to a solid diet that they're able to hunt.
You also mentioned earlier uncertainty regarding the mixing of European taupe populations, and also tag returns from places like the Azores, which as we all know are isolated from the rest of Europe by waters many thousands of metres deep. Certainly way too deep for taupe to be following the bottom contours. Surely then these fish must be making a fairly determined mid-water to surface migration out of keeping with the normal regime.
This is a great question actually, and one of the first things that I'd like to say is that this really shows the value of angler-based mark and recapture data. This information isn't coming to us from fisheries markets, this information isn't coming to us from governmental scientists, this information is coming to us from anglers. Anglers tagging, and on the whole, it's anglers returning the tags. There's a little commercial interest around Europe when they return tags and they get found at fish markets and things. But on the whole, this is a volunteer angler project that's created this data. And you're right, we've had fish tagged here in Luce Bay. They've turned up in Iceland, they've turned up in the Azores, they've turned up even in the Mediterranean, the Canary Islands. This is a huge geographic range. You mentioned, to get to the Azores, they're travelling over very deep water. A bottom-feeding fish, I very much doubt that they're feeding off the bottom on their way over to the Azores. You're talking about thousands of metres. There was some tagging work done in Australia that showed tope do go down to about 800 metres. Whether they're feeding down there, I don't know. My guess would be that they'd go down deep, but they wouldn't feed off the bottom when they're in kind of the plain regions off the continental shelf. My guess is they'd be using it more just to travel, and the depth gives them a slight amount of safety, because in the grand scheme of things, tope are actually quite small, and there's a lot of bigger sharks out of there that would find them quite a tasty treat. Now, you asked where the tag movements, do they show migration? Well, yes, they do. Now, the problem with the mark and recapture data is I don't know if that tag recapture just happens to be a one individual that got lost. I don't know if we tagged a fish here, one fish out of a group of 30, and that group of 30, for instance, moved down to the Azores. It's not giving us the full picture. It gives us yes, they do this, but it's not actually explaining how many of them do it, how regularly they do it, and where else they go. It's a snapshot image that needs the rest of the detail filling in.
Now, as I sit here listening to your responses, all sorts of other questions start popping into my head. So let's try to deal with these now in some sort of meaningful chronological order, starting with the funding and inspiration behind the project itself.
To give you the background to the project, it's a little tricky for me. Obviously Sasakan have had interest in the shark tagging programme for longer than I've been involved. My interest, when I was doing my Masters, I was approached by, or to be honest, my university was approached by Scottish Natural Heritage, who had gotten hold of the Glasgow Museum's skate data. And they basically wanted someone to look over this data, which I got as my Masters project. And I really got into the British elasma banks through this project. And also it made me very aware of angler involvement as well, something that I will openly admit I was a little naive about and I had very little information about before. However, once I got involved in this project, I saw the great potential it had. And this is when I started to talk to Sasakan, as they now hold the Glasgow skate tagging data, as much as they also hold some of the UK shark tagging data, as they've contributed to a lot of it themselves. And the idea of a project officer for the Scottish shark tagging programme came up. Now, this was a one-year post to really get the ball rolling, and I was lucky enough to get that job, and I obviously worked incredibly closely with both Scottish Natural Heritage and the Scottish Sea Angling Conservation Network on the Scottish Shark Tagging Programme. And as I was working on the project, I found that every time I got a tag return, every time I talked to somebody, I'd get really excited about what was happening out there. For me, this is... You get the people who wake up in the morning and love to go to work. That's where I'm at now. This is a fantastic job and I absolutely love it. And that excitement and that interest came from the project officer position. I was finding all these questions kept popping into my head, saying, what are they doing? Why is this happening? And I thought, hang on a minute, there's a Ph.D. here. Now, you might ask why a Ph.D. Basically, Ph.D.s are relatively easy to get money for because we're students, and the universities or employers don't have to pay us as much as a full-time researcher. And also, to lead your own research really in the academic views and through academic eyes, you need to have that doctorate training. The Ph.D. is your first level of training. So as I was the project officer, I started to think into this, and I began to chat to a few people at SNH and other various marine research institutes, and I began to write a Ph.D. proposal saying this is what I'm interested in. Now, the tope held a special fascination for me just because it's a relatively large shark species. Swimming in our waters, most of the year it's within one part of the UK, and nobody knows about it. It's nearly a 2 metre long shark species that's you can catch from the coastline, and nobody knows about it. It's a fantastic animal, and there's so little data out there. So I wrote the Ph.D, and I took it to a few places. This is where Aberdeen, the genetics, Kath and Les got interested, Francis Neat, the Marine Lab, and David Bailey at Glasgow. And I was lucky enough to get funding for my Ph.D. through Aberdeen and MAST. Now, MAST is the Marine Alliance for Science Technology in Scotland. It's a massive umbrella organisation, would maybe be the best way to describe it, that are really supporting networking of marine research within Scotland. And they funded my Ph.D., which was fantastic. And I started my Ph.D. and I thought, you know what I'd really like to do? I'd really like to get some data storage tags out on these animals, but unfortunately they don't come cheap, and I was lucky enough to get some funding from Scottish Natural Heritage and also the Fisheries Society for the British Isles. They funded my tagging work at the moment, so I've had funding sources from a few different places, and I'm very lucky to have that, so I'm very appreciative for all of that.
That nicely takes it on to the different types of tags. What are the different options, the plus and minus points, and what types of meaningful data can you hope to get from each?
To start off, basically, we've got the mark and recapture, the ID tag. Now this is really called a conventional tag. This tag assigns a unique number, an ID number, to each individual that the tag's attached to, and allows us to see movements, basic movements from point A to point B. Sometimes animals are recaught many times. This happens a lot with the common skate in the Sound of Jura in the Crinan area, as well as the Firth of Lorne. And you can begin to build up a movement pattern, point A to B, even to C, D. I think one of the skate have been caught nearly 8 times, and she's been nicknamed Yo-Yo. She's up and down so many times. So that's the basic form. Now, the great thing with mark and recapture, the ID tags, is the fact that you can get anglers and you can get volunteers involved. As well as data collection, and it does produce some really useful data, this also has a massive public awareness campaign almost. It really lets people know what's out there. If you start a tagging program for something, people take an interest in it and they almost begin to feel a sense of ownership for that species. It's a really great way to do that. And as I mentioned, it shows us some great movement data. We know that fish here go to the Azores. The problem is, as I have mentioned, we don't know what they do in the middle. There's a massive gap between those capture incidences that we just don't know anything about. So they're very cheap to buy, they're relatively cheap to implement as a volunteer through a volunteer network, and they do provide basic information. They're really what I'd call a preliminary study. They're the first step. They provide us with the basic information and show us where the next lot of questions are. Now for me, the next sort of round of questions are electronic tags. These come in various forms. The ones that I've used for my project are acoustic tags. And when I say acoustic tags, I basically mean that the tag is attached to the fish or internally implanted, and it actively sends out a sound signal. Now these sound signals are picked up by hydrophones that we place in the water. Obviously the hydrophones are limited to the area that they can hear, say about 1/2 to 1 kilometre radius around them. Depends very much on the local bathymetry, the sea floor, the water quality, noise in the water, things like that. But it basically shows us if a fish was in the area of a hydrophone. Now if you have a network of hydrophones, you can begin to build up movements around those hydrophones, or somewhere like Loch Etive with a very narrow mouth, you can put a gateway and see if fish have moved in or out. Now these tags are great. Now you might be asking, how do you know which fish is which? Well, each tag has a very unique sound signal, almost like Morse code, so you can actually identify individual tags. The problem with acoustics is, in terms of electronic tags, they're actually quite cheap, but once the fish is moved out of the range of the hydrophone, we don't know where it's gone. It's like the next step up from mark and recapture. It's continual monitoring, but it still has that limitation. You can get active acoustics where you can actually follow the fish about, but this is highly intensive and very costly because you need someone with a boat and you need to be able to follow the fish for hours, days, weeks at a time. I'm certainly not following a taupe all the way to the Azores in a small boat, that's for sure. But as I mentioned, they're actually quite cheap, and they do provide some great data, and the developments of acoustic tags are fantastic, and they're beginning to make ones that now record other environmental parameters and download it to the hydrophones, and it moves on and on. Unfortunately, the more complicated you get, the price goes up as well. So I have used those in Loch Etive to a certain degree of success. They've shown movements in and out the loch. But again, to really follow the fish every minute of its life, it might sound a bit intrusive, verging on stalkery, but that's the way we get when we get a little bit hooked up on something, if you'll pardon the pun. Data storage tags, archival tags, are the next step up. Now these tags are great. They're basically memory cards with sensors. You pick which sensors you want. For instance, I work a lot with depth, temperature and now light levels, but you can also get other things like salinity. You can get things like internal body temperature, and much like your iPhones, they can detect pitch and roll and the angle that the tag's at. They're phenomenal. Now what this does is that obviously the more environmental parameters you have, you've got much more chance of recreating the fish's movements, both horizontal and also vertically, i.e. up and down in the water, and from point A to point B and all the points in between. This sounds fantastic, and you might be saying, oh, why doesn't everybody use these? Well, they are riddled with a few problems. First of all, they're not the cheapest of things in the world, but that's not the main problem. The main problem is if I put a tag on a fish, I need to get that tag back, which there isn't any commercial interest in these species anymore. They're not allowed to fish for them. So unfortunately the commercials are the guys that tend to return the tags because they come with a reward. The other problems with them is you also have to be able to recreate from that data movements. I mean, light level can give us approximate latitudes and longitudes, but you're still talking about errors of 50 to 100 kilometre on these latitude and longitudes. They're not exact, they're not precise. The next step up from an archival tag is something called a pop-up archival tag, which basically is exactly the same as a data storage tag. It records the environmental parameters, but at a certain point it detaches from the fish, floats to the surface and downloads the data to me via Argos satellite. Now the obvious advantage of that is I don't need to recapture the fish, I get the data back. The disadvantage is the cost. They're about 10 times as much as the data storage tags. And also the data is sometimes packaged to allow it to travel to the satellite and back, i.e. you don't get the full resolution, you don't get as many records. But again, this is a step up, and it also gives us an endpoint. That's quite a useful tool as well. Moving onwards from the satellite pop-up tags, you actually get GPS tags. These are tags that, almost like your TomTom, they continually transmit their location. Problem is they have to see a satellite, so they have to be above the surface of the water. They're great for things like basking sharks and some marine mammals. For many of the British shark species who spend a lot of their life on the bottom, anglers mainly fish for British sharks off the bottom, because they're bottom feeders, they're benthic dwellers, these GPS tags are useless. So you have a kind of compromise between how much money you've got in your budget. The ideal would be the pop-off satellite tags, where you can pay to have a massive bandwidth on the satellite and you get all your data back. But, at 10 times the cost of a standard archival tag, it's not always clear which is the best option. You have to also realise these tags aren't faultless. Sometimes, you might invest in 10 tags, 1 or 2 of them fail. When you start talking about satellite tags, that's a lot of money you've just lost. While if you get 1 or 2, but 10 times as many of the archival tags, then it's not so bad.
So you've potentially then got various strands to your data gathering, from which you will hopefully demonstrate what?
Well, the reason I picked so many different technologies and so many different pathways to answer the question is that none of them answer the question completely. Each one gives a new piece of the puzzle to hopefully give us as accurate a picture as you can hope for. The overall goal, and this is true for both species, is it's very difficult because obviously I'm only targeting a few individuals, and to try and imply a population does something based on the movements, the behaviour of a few individuals, is potentially a long shot. But what I'm hoping to show is how spur dog and tope populations move around the UK and further into Europe, how they utilise certain habitats around the British Isles, especially in Scotland, and the ideal would be to try and locate critical habitats for them, i.e. nursery areas, breeding grounds and any particularly important feeding grounds. That's the aim of the project in a nutshell, to see how they move, what they do when they get there, and how much these populations around are actually mixing together. Is it one big population or several little populations?
Now I know that Sasaken have also been a major driver in all of this, so explain to us their overall role, objectives, and how this particular project could arm them with more information to take where and to do what with.
Yeah, of course. Obviously Sasaken are fundamental to the development of my Ph.D. from start to finish. The fact that they had mark and recapture data there in the form of the Scottish Shark Tagging Programme really gave me the first step on the ladder towards my research. Not only that, I obviously work with Sasaken, but I also work with a lot with anglers, because anglers are a fantastic source of information. You go to many of the local spots, and I can be armed with as many scientific papers, journals, books as you like, but somebody who's fished their local area for years has so much more information on the area than I could ever hope to get. So they're a wealth of information, they've got a lot of local knowledge, and to be honest, they help me catch the fish to do my research. So the way Sasaken are currently helping, obviously they keep me up to date on their mark and recapture data, as well as providing me with opportunities to get out and do my research, i.e. put the tags in place. Some of my research took place during my role as the project officer. For instance, the acoustic project at the mouth of Loch Etive, that took place while I was actually working with Sasaken. So they were obviously fully supportive of my work there. My work will hopefully fill the gaps that their mark and recapture data has. Obviously, Sasaken are very driven towards ensuring the future of fish populations within Scotland. They want to make sure that their children, their grandchildren have tope and spur dog to angle for. However, it's very hard to persuade government to put management procedures in place and to protect animals, to protect certain areas, without hard facts, without any evidence. You have to have supporting information behind your statements. You can't just say, we want this area protected because we think. You have to go to them and say, we want this area protected because we know. and hopefully my project will give them more we knows than we thinks.
What about the other cartilaginous species? Are there others also in need of similar studies being carried out?
We're very lucky in some aspects in the UK is the fact, I'm studying taupe and spur dog, however both actually enjoy a relatively high level of protection. They're no longer targeted by commercials and they're no longer landed as bycatch, and that actually implies to the rest of Europe as well, pretty much. So immediate all-encompassing legislation to protect them isn't really needed anymore. However, what is really interesting is, I touched on this a little earlier, but it's widely thought that a marine protected area as a static management, a static protective area, is going to be really ineffective at something as highly migratory as a taupe or a spur dog. I mean, for instance, if I was to say to you, let's protect Luce Bay for taupe, and then I'm saying, but they swim all the way to the Azores, I might protect them for 2-3 days of their life, for instance. So it's important to find where they spend a lot of time. If there's any areas they spend a larger proportion of their time to others. Now, as I mentioned, taupe are data deficient. We know very little about them. We were out there today and we caught huss. They're in a similar situation. There's very little known about them. And there's plenty of other shark species, elasmobank species, skates and rays included, around the British Isles that we either know very little about, or we got to a certain point with them where they were caught commercially, the populations decreased, we stopped fishing for them, and all of a sudden the question mark came up, what's happening to them now? Are they recovering? We just don't know. Smoothhound, for instance, is another species that has had, migratory-wise, very little work done. There's a gentleman, Ed Fowles, done loads of work looking into the possibility of one species of smoothhound rather than the two preferred, starry and common. Again, that just shows us how little we know about them. In my view, there's never enough known about the cartilaginous fish around the UK, and many of them need more knowledge on them to make sure that we manage them effectively. The problem with cartilaginous fish, especially sharks as a whole, is the fact that they mature late. I mean, I'm sort of talking 8 years upwards. That's nearly the same as us. Okay, 8 isn't, but the common skate, for instance, is 15. And then when they do start to breed, and when they do start to produce offspring that can recruit back to the population, you're talking about very low numbers. I mean, as low as 6. 6 fish from one female is not a lot. When you look at things like cod, and they spawn, and there's millions of eggs going around, and yet we've got the sharks here, and they're producing 6 or 7 offspring. I mean, they do produce more as they get bigger. The other problem is these pups come immediately out the mother or the egg cases, and they're immediately vulnerable to fishing gear because of their size. They can get caught on hooks, they get caught in trawl nets, they get caught in pots. So they never really get a chance to breed and to put back into the population. This is something we call a K strategy, which basically in a nutshell is late to mature, slow growing, and low fecundity. Now, fecundity is just the number of pups it produces, it's low number of offspring. This all works together to them, so if a population is decreased, it takes a very long time for that population to recover, and obviously you have a slightly lower genetic diversity than you would have done originally.
To counter that, though, there are some elasmobranch species which are now on the increase. The smoothhound, for example, and as anglers know only too well, the lesser spotted dogfish. Are there any particular reasons why this should be so, while the reverse is still true for others?
Yeah, I mean, you talk to anyone and dogfish seem to be the number one enemy, which is actually a bit of a shame because they're quite a pretty little fish when you see them up on the deck of the boat. I mean, you're shaking your head, and I agree. They're a pain when you're trying to get anything else and all you get is doggy bites all day. There are reasons why this has happened. So something, as I mentioned to you earlier, some shark species mature a little later than others. The common skate at 15 years is one of the oldest. Spur dog are similar, they mature very late. Something like a lesser spotted dogfish actually matures at a much earlier age, and that means they're able to put back into their population a little quicker, their generation time shorter, so they can actually build their population a little quicker. So just to give you a really rough example, if you have a certain area with 5 different species of sharks in there, verging from small things like a dogfish up to the common skate, one of the problems is that sharks are top predators. Okay, some of them are slightly higher, something like a common skate will actually eat dogfish, but smaller skate will be competing for food sources such as the same as a dogfish would eat, and they do eat very similar diets. So when you get an example in an area where something like a large predator, for instance the common skate, has been depleted, it leaves a niche open, and animals are going to take advantage of that niche, are faster growing, faster replicating, bigger potential potential to expand their population. This is the lesser spotted dogfish, and in some instances something like the thornback ray. They are still slow compared to other fish species, but in terms of competing against some larger elasmobranchs, there'll be a lot more food availability because the larger elasmobranchs aren't there to predate on these animals. So you've got the situation where you've got limited competition, an abundance of food source, and this allows populations explosion such as we're seeing in something like the lesser spotted dogfish. So this is actually a sign of the depletion of other shark species, the fact that the lesser spotted dogfish has now had this chance to grow. This is true for, you see it with smaller skate in areas where there used to be things like common skate. You see the smaller skate species, some smaller skate species doing slightly better. I mean, obviously somewhere, like Luce Bay, where it's well known for its skate and ray fishing, and now you're looking at very low numbers. There's some skates that just obviously that's not truthful.
Could this also in part be because of the overexploitation of other highly prized species such as the cod being removed as a predation threat, leaving more small fish and invertebrates for less desirable species such as dogs to wax fat on?
Yeah, potentially. I mean, it's very hard to take anything away from an ecosystem without upsetting a balance. Even done in a carefully managed manner, there's still going to be some unseen balance, and especially in the marine environment it's so hard because you can't monitor it 24 hours a day. You can't get a full picture of what's happening. I mean, some of the cod, we caught small codling today, I believe, and it actually had quite a lot of langoustines in its gullet. Langoustines are something that dogfish are going to want to eat as well, so yeah, if you take the cod away, there's going to be more langoustines, which, again, food source for a voracious predator that's fairly happy to eat anything.
Now, I know it's early days yet, and as any scientist will always tell you, more data is always needed to reinforce whatever initial hypothesis started the project off. That said, there are always going to be early trends, which over time, more data will help to reinforce. So what can you tell us about where the project is up to so far?
Many scientists might tell you that it's more data needed, but most of the time it's more cash is needed, to be honest with you. Yeah, it is early. I'm only about halfway through my project. I spent most of the first year trying to plan it. However, we're getting some really interesting insights. Most of my current work's taken place on the spur dog. The interesting thing is previous research focused on offshore stocks has shown this mass movement of animals all over the UK with no real pattern. But it looks like we have a situation where coastal species, such in areas like Loch Etive, might actually show almost, it's called philopatric behaviour. Now, when I say philopatric behaviour, basically what I mean is they show a strong site affinity or strong preference to a certain area. Much like salmon always return to the same river to breed. It looks like something similar is happening for the spur dog, where they're in Etive and it's a very important habitat to them. They overwinter outside of the loch for maybe due to a temperature decrease in all the fresh water in the surface layers of the loch, or potentially in line of a breeding cycle. But then they come back to the loch, and I've had 4 fish. I know 4 is not a lot of fish, but it's beginning to build up a pattern. As always with science, more questions asked than ever answered. But these fish all leave the loch at the same time and all re-enter the loch at the same time. Not the same day, but 4 or 5 days either side. It's quite a striking pattern. This doesn't sound like a major breakthrough, but for us in the UK, this is the first evidence of this type of behaviour. So, it's in line with research from other areas, but it's the first time it's really been shown in the UK, so it's a really interesting feature.
What about the preliminary trends from the DNA?
Problem with DNA analysis, it takes a lot of lab time, and I'm still collecting a lot of samples. I've been very lucky. I've had a very positive response from the angling community, and they've been incredibly enthusiastic about collecting me small fin clips from the dorsal fin. I'm still collecting these. I mean, I've got a massive library now of fin clips from all over Europe for the taupe, and certainly a great area of the UK for the spur dog, which is fantastic. Still collecting them. There's still a few areas I'd like to explore, get fin clips from. But most of the genetics work is going to take place from about August, September this year over to about Easter next year. Hopefully by Easter next year I'll have all the data back. It's when I start analysing and that. So I'm hoping to start having some sort of insights into the population genetics, the way that fish move and breed between certain locations by next summer. So by the end of my project I should have good data from the tags and good data from the genetics, which should all come together to answer these questions.
And in the final analysis, what does or will this mean in pure angling terms?
In pure angling terms, I'm hoping that my project will give anglers a kind of multi-level benefit. Firstly, it will show the benefit of anglers as a science source, as a basis of knowledge. I mentioned this earlier, I can read as many papers, as many books, I can spend days, months reading, and then I'll spend a couple of days out in the water and all of a sudden I'm an expert in that animal. But I'll travel to various locations around the UK and I'll speak to someone who's fished that water for their entire life, and they will just completely change the way I think. They'll have so much knowledge on their little area that I just never hoped to gain. So I really want to promote anglers as a civilian science source. There's a lot of worthwhile potential of scientists and anglers working together for both benefits. The other potential benefits in terms of anglers is I'm really hoping to get more in-depth knowledge of fish movement to show the benefits of MPAs. It also shows that angling mark and recapture data is very valuable, and angling in itself, it's not a destructive sport, and if anything it provides far more benefits than it could ever do negatives. And the sort of ideas behind angler only areas, hopefully my work will all feed into that and really promote it.
From what's been said, anglers are being cast here in a whole new light and should feel proud about the way we're currently being perceived by the scientific world. We have had some bad press over the years, and often deservedly so. But lately it seems we've come of age by contributing, sometimes at considerable personal expense, to the better understanding and conservation of many of the fish species we cherish, and never more so than in Scotland, where a number of annual mass tagging events are staged by Sasakin to potentially generate more data for people like James to work with. So a very big thank you then to James Thorburn for explaining what happens to the data once it's been gathered in. And at a more personal level, also for inviting me along with himself and Ian, where we've also been filming a range of angling and safe handling techniques to go on the Sasakin website.